In this experiment, Drosophila, or fruit flies, are placed in a tea maze and presented with a choice of air environments to test their sensitivity to specific odorants. The flies are transported down the maze in a central elevator to a choice point where they have the option of entering either arm of the maze. In the control trial, both arms of the maze contain fresh air. As we observe, the flies show no significant preference as to which arm they enter. In this experimental trial, the arm on the right contains air released from flies that were mechanically stressed by shaking. The arm on the left is filled with fresh air. As we observe, a vast majority of the flies choose the arm with fresh air. It is clear that the flies can detect and avoid an environment that contains the substance released by the shaken flies. This graph represents the avoidance behavior of Drosophila in various trials of the experiment. The y-axis represents the performance index, or PI, which measures the distribution of flies in the two arms. If half the flies locate to one arm and the other half locate to the other arm, then the PI will equal 0, indicating that there is no preference for either side. In the control trial, both arms contained fresh air, and the PI is close to 0. In the trial with one arm containing the air from shaken flies, the preference to avoid that arm is high. Observe the difference between this and the control trial. In later experiments, researchers established that carbon dioxide is a major component of the substance released by shaken flies. In these experiments, researchers performed the same experiment with each arm containing different levels of CO2. The direct relationship between the performance index of Drosophila and the carbon dioxide levels of the experimental arm indicate that flies show an innate avoidance behavior to CO2 in a concentration-dependent manner. This ability to distinguish smells helps organisms locate food, find a mate, or in this case, avoid potential harm.